Welcome in Core. Astronomers are always looking at the universe and discovering new planets, stars, and other amazing things that blow our minds. Now, scientists have recently found an incredibly bright and mysterious light that's nearly as old as the universe itself. But what is it that they found, and why is the light from this massive object so bright? In 2019, astronomers discovered a 13-billion-year-old light coming from a distant quasar. Quasars are massive and extremely remote celestial objects that emit incredibly large amounts of energy and typically look like a star when viewed through a telescope. But it is what lies at the heart of the quasar's light that's the most impressive. It's said that quasars contain massive black holes and may represent a stage in the evolution of galaxies. What they found amazed and surprised everyone. A massive black hole that formed so early in the universe that it would have to have an incredibly huge solar mass amount, and mysteriously, it was created 100 million years after the Big Bang. It was given the indigenous Hawaiian name Niuena to honor its discovery from Mauna Kea. The quasar provides scientists with an idea of what the universe looked like millions of years ago. What can astronomers learn from this black hole, and what does this mean for the future of the universe? The name Niuena translates to unseen spinning source of creation surrounding with brilliance and was captured by astronomers using the University of Hawaii's Institute for Astronomy's Pan-STARRS 1 telescope on the island of Maui. The nearly 6-foot diameter telescope is safely stored on the summit of Haleakala. It features the world's largest digital camera with almost 1.4 billion pixels and is a real treasure to employees at NASA. The data collected by the Pan-STARRS 1 telescope was critical, but it took a lot more than just looking through a telescope to find this massive black hole. The W.M. Keck Observatory provided the near-infrared echolette spectrograph to confirm the existence of Niuena. The over 32-foot optical infrared telescope includes a suite of advanced instruments, from multi-object spectrographs to integral field spectrometers to a world-leading laser-guide star adaptive optics system. In addition to the near-infrared echolette spectrograph, astronomers also utilized the NIRS instrument in the Gemini Observatory. Once the presence of Niuena was established by both tools, scientists began to understand the incredible magnitude of this discovery. There's so much more to unveil with Niuena than any previous quasar. Quasars are known to give off an immense amount of light energy, but Niuena is especially brilliant compared to those spotted previously. A quasar found in 2018, known by the name J1342+0928, pales in comparison to both the glow and size of Niuena. Spectroscopic observations unveiled the black hole hosted by this quasar contains a mass 1.5 billion times that of the Sun. That's what makes Niuena especially unique. It's the only known object in the universe that has a capacity to host a black hole that's greater than 100 billion solar masses. This created another missing puzzle piece in the enigma that is Niuena. In order for this quasar to grow into such enormous power, it was most likely born approximately 100 million years after the Big Bang. This begs a question: how can the universe produce such a massive black hole so early in its history? Typically, a black hole of such size would grow from a smaller black hole that originated from the destruction of a star. However, Niuena disproves that such a theory is relevant in this circumstance and instead suggests that the black hole started off as a 10,000 solar mass seed black hole. The creation of galaxies and stars is believed to have begun during the epoch of reionization, around 400 million years after the Big Bang. The ionization of hydrogen gas led to the development of the first quasars and black holes. Before the epoch of reionization, there was no source of light present in the universe since radiation was typically consumed by hydrogen gas. Now, with the confirmed existence of Niuena, researchers had the opportunity to further explore the process of reionization to gain greater insight into the development of black holes. The quasar has been described as a cosmic lighthouse. As its light travels a long journey toward Earth, its spectrum is altered by diffuse gas in the intergalactic medium, which allowed researchers to pinpoint when the epoch of reionization occurred. The massive nature of this black hole is almost entirely incomprehensible, making it difficult to truly comprehend its significance. Scientists are able to calculate the mass of such a black hole by studying the movement of stars in the center of various galaxies. By evaluating the speed of these stars, we can understand the mass of the black holes themselves. How do they form? These formations grow so large from absorbing immense amounts of gas over billions of years. They consume everything that crosses their path, and their incredible size creates more opportunity for them to swallow up any object in their gravity. As these objects are dragged into the black hole's pool, they are heated to millions of degrees, which results in glowing X-ray light. Nothing can escape the strength of a black hole's gravity. Nothing. However, scientists have only been able to spot a few young cosmos despite thousands of galaxies existing in the closest universe. Since the illumination from the X-ray takes time to travel, studying these areas of the universe requires astronomers to virtually look back in time. There are two main theories as to how black holes are formed. One theory suggests that black holes originated from the first generation of stars. These stars, made up of helium and hydrogen, quickly developed into enormous beings that were possibly hundreds of times the size of the Sun. They did not last very long in the universe, though, and their collapsed cores were all that was left after their inevitable death from titanic supernova explosions. Thus, a black hole was born from their leftover cores. The second theory works off the premise that black holes are not related to stars whatsoever. The first black holes were actually a result of unstable clouds of gas that eventually collapsed. This theory explains how the existence of gigantic black holes can be dated back to millions of years ago. How do they affect us? Scientists continue to grapple with these two opposing theories, illustrating just how little we know about the origins of these great bestial black holes. With the largest black hole in the known universe containing a mass 66 billion times that of the Sun, known by the name TON 618, the magnitude of these entities continues to baffle scientists. Fortunately, astronomers are not completely clueless about black holes in our universe. For starters, NASA has determined that it's impossible for a black hole to swallow up an entire galaxy on its own. Although their gravitational pull is quite powerful, it's not substantial enough to ingest an entire universe. No black hole is located close enough to our solar system to pull any object in, but scientists have studied what the potential consequences of falling into a black hole would be by observing stars. While stars that fall into their gravitational pull are ripped apart, humans would experience a process known as spaghettification. The strength of a black hole would stretch one's body vertically while simultaneously compressing it horizontally. Both the perception of time and space are altered when falling through a black hole. While outsiders would only be able to catch a glimpse of the exterior of the mass, the person experiencing the fall would suffer a warped idea of what reality means. With the Sun being the largest star in our solar system, some used to fear that it could explode and create a black hole that would inevitably suck everything into its gravity. But have no fear, the Sun is not large enough to explode and will instead become a white dwarf. Even the hypothetical explosion of this star would not create a black hole large enough to swallow the planet Earth. The Sun's gravitational strength would remain stagnant, meaning that our planet would continue to revolve around it as normal. While we do not have to fret about a black hole consuming Earth anytime soon, the creation of black holes undeniably affects all living things that reside on our planet. When black holes collide, elements such as oxygen and carbon are released into the universe. These elements can potentially contribute to the future creation of planets. Stars and entire solar systems can be formed by shock wave from stellar explosions that lead to black holes. The connection between black holes and galaxies is still unclear. Astronomers are not entirely sure whether the development of a black hole eventually led to the Milky Way galaxy, or if the Milky Way actually came first. However, it's clear that black holes did contribute in some way to our solar system, even if it's not entirely clear how. This means that everything we know and everything we are is due to the creation of black holes in the universe millions of years ago. Famous physicist Stephen Hawking determined that though the overwhelming presence of black holes is intimidating, black holes cannot remain in their massive states forever. Known as Hawking radiation, small amounts of energy are lost due to the nature of the vacuum. The vacuum is not actually ever empty, as particles are constantly entering and exiting. When a pair of such particles approach a black hole, one has the opportunity to escape, as the other is sucked into the gravitational force of the entity. The energy that allows one particle to enter space and get away comes from the black hole itself, meaning that the black hole loses part of its mass in the process. Since this process is slow, black holes that make up the universe are expected to remain for millions or billions of years before shrinking. NASA has confirmed that while the black hole in the Milky Way galaxy seems threatening with a mass of a few million times that of the Sun, there is no chance of it consuming the planet Earth anytime soon. At this point, it has swallowed almost all the stars in its gravitational pull. Even if it's able to ingest a few more stars, it only has a capacity to grow in small increments. Galaxy collisions could potentially cause black holes to expand, but it's highly unlikely that these events would disrupt the balance in our solar system. Remember that Nuena is the second most distant quasar discovered. No matter how ravenous and powerful it may be, it remains very far away from Earth. Do you think there's more to learn from Nuena and the black hole that powers the quasar? Let us know in the comments. If you liked the video, please be sure to smash that subscribe button and turn on notifications so you'll be the first to know when a new video is released. Thanks for watching. Cool.